Hello friends, this is Rajiv Ranjan, MTech scholar from Bennett University. Here I am going to present a video on vehicle detection and speed tracking from videos. So in this project, the vehicles are detected from the video surveillance across the street side and on the highways. So let's see inside it. Vehicle detection and its speed tracking from the videos is an integral part of intelligent transport system. So that is detecting the vehicles from the video surveillance in the cities are really making the traffic system very intelligent because it detects the moving vehicle through the videos, and it will also help us to record the traffic condition over different parts of area and city and on highways, so that we can monitor and see the overview of traffic condition anywhere in the city just from the control room, and it will make coverage of the whole traffic management system. So the methodology of this project is first traffic under observation, and the observation will done through the camera. After that image digitization and storage. So whatever the image is captured by the camera is going for the process for the digitizations. So various image processing methods are included in this image digitizations. So one of the important image digitization is image subtraction, so that the detection of the vehicle can be done, and after that image is segmented into different categories and the feature extractions is done. After that, the classification and identification with various formulation, we can track that vehicle. So here I am using OpenCV for vehicle detection and speed tracking. OpenCV is open source computer vision library, and I am using this library for the Python programming. So some of the requirements for program for this program is installation of Python 2.7 version, installation of OpenCV 2.4 version, and proper running of NumPy in Python. So NumPy is one package of Python programming language. So these are the requirements should be installed in our system to run this project. This is the programs codes for the detecting vehicles from the videos. So step by step I can just explain you. Like first I have imported OpenCV as CV2, and then the second code is to take a frames from a video. So capt means capture equals to cvt.video capture, and video2.avi is the video file, the input video file I am giving. So we can take any video file here, and after that it will provide a training to classify by using some features of object to be detected. So first you have to generate vehicle.xml file. We got XML file after the training of datasets. So I have trained my data with the approx 526 images of vehicles, and after the training I have got this XML file, so we can put it here. And after that, running this loop, right? So these are the codes for image processings, and here cv2.rectangle underscore vehicles frame. So this code, this line is for generating a blob once the vehicle is detected, right? So the next thing is to just show the video of frames, the output video, cv2.im show, and this you can finish this program with cv2.destroy all windows, and this is the simple program to just detect the vehicles from the video. uh, one thing has to be considered, that um, the calibration of camera is very important for this project. So whatever the input video you are giving here, so the training data set will be related with that video only. If we are using we used a different video, then we should have the training of the data set related to that scenario, right? So this was the part of programming. And next I have some mentioned here about the classifier training. So after getting this code in Python, we have to train the system by cascade har classifier. So cascade har classifier is a type of classifier, so that it will classify the objects once it got trained. So for this we need three types of data set: negative images, positive images, and the webcam images. So negative images include all the views which we don't want to be detected, like the views of road, the trees, and any another objects, so that are negative images. The positive images is the real images of vehicles, and the webcam images is that images that we are recording. That part of the images that we are getting from the recordings of video surveillances. So now this is the data set of webcam images, so that the perfect camera calibration can be found for training purpose. So once I have told you that the calibration of camera angle is very much important. If the camera is mounted horizontally or overhead, so in different situation the programming code, the training data set got varies. So for the whole system, it depends on the calibration angle of the camera, so it should be take care of. After that we'll get the result, and we get result in this form, like after providing this input video, it will project the output video like this, and it will detect every vehicle passing on this road on both the lanes, and generate a blob on that vehicle once it detected. You can see it here, the blob of red rectangle is detecting the vehicles. So this is the output, and you can also see the countings of that vehicles if we include the programming of counting the vehicles, or so that we can also here detect the number plates of vehicles, so that we can keep the record of all vehicles passing through this highway. So this is very important features of this project. But to get this result, we can face some challenges, like various challenges like dynamic state of vehicles, the weather conditions, if there is so much fog and raining, so it might be happen that camera is not working properly, and the other moving objects has an obstacles. It can be obstacle, and dealing with the shadow of the vehicles, and variance in lane changing by the vehicle. If vehicles are suddenly changing the lane, then it can somehow creates a problem, and camera calibration angle is always a problem. And if we track the speed of that vehicle, so the programming part become very complex. So these are the challenges, and I am working on these challenges, so kept on these things on as a future scope. So as soon I'll overcome with these challenges. So in future scope you can see that if I will able to overcome of those challenges, then I could also able to track the speed of that vehicles what I have detected through the video surveillances. So just I will do that. I will put two imaginary line on highway, and I will calculate the entry point of this vehicle through this first imaginary line, and also calculate the exit time through the second imaginary line, and then with the help of certain formulation I will get the speed of that vehicle in the video frames, and the GUI output will be here. The number plate of that vehicles could also be detected, and then we can calculate the types of speed. So far the speed limit laws can be applicable, that if the vehicle is crossing the limit of the speed, then it could be able to detect it and inform to the nearest control room, right? So these are the best features of this project I have done, and it will definitely help the traffic system and make it very much intelligent. And that's it. Thank you.